Okay, what is x to the 0 power? One of those answers is right. You took pre-calculus, right? It's 1. Anything to the 0 power is... Yeah, let's... Oh yeah, I know, it's been like months. X to the power of 0. Oh, ain't gonna work. Well, let's go 6. I wonder why that doesn't work. 6 to the power of 0 is 1. If x is 6, then it's the same thing, right? Okay, so anything to the 0 power is 1, all right? So essentially, what can I do with that x to the 0 power? Make it a 1. What's 3 times 1? F of x is 3. Okay, there's a function. Okay, this is what we call the degree. It's degree of 0. Remember that word? Okay, so that's a constant. It's just 3. Do I care what x is? It's 3. It doesn't matter what x is. It's 3. It's constant. And to graph this thing, well, this is now x, but I'm not going to call that y. I'm going to call it f of x, a function of x. Think of it just as y, same thing. Where is this function equal to 3? Right there, right here, right there, right there. Do I care what x is? No. The output is always 3. It's constant. Okay, y is 3. Doesn't matter what x is. And then in grade 10 we did a lot of that. Remember, y equals mx plus b. Got slope, we got a y-intercept, but every case, what's your degree here? What's the exponent on x? It's a 1, right? We just don't write it. And this always makes what shape? A line. And if you recall, well, that would be the y-intercept. If I'm going to graph this, this is where I start. The y-intercept is -2. Okay? -1, -2. I know it has to go through that point. My slope is 4. I got 4 units of rise. 1, 2, 3, 4. 1 unit of run in the positive direction. There's 2 points. That's all I need to make a line. Or plug it in your calculator. 4x minus 2. Graph it. Does it look the same? Sure does. Okay. Like this is, you shouldn't use a calculator. Like this is easier than using the calculator, okay? But I'm not going to say you're not allowed to use it. Okay, so and then you got to grade 11 and we looked at something like this. Lots in pre-calculus, not so much in foundations, but we did do it, okay? Maybe half the amount of time. Actually, in a lot of cases, the foundations kids knew some stuff better than they did in pre-calculus because we spent more time on it. But maybe not quadratics. That's what this thing's called, right? That is a quadratic. What kind of shape does it make? Yeah, parabola. Okay, and again, pre-calc, we kind of did this quite extensively. What happens, like if I let x be 0, what happens where x is 0? That's what we call a y-intercept, right? Every point on here, x is 0. So if I let x be 0, I get 1. That's where my y-intercept is. 2 makes it different shape than if it was just x squared. But for right now, all we need to know is, well, that makes a parabola. Does it open up or open down? up. It's positive. It makes a shape like, yeah, that's right, 50-50, like that. Okay? But hey, you guys got one of these? Yeah, not today. 2x squared plus, what was a 1? Bingo. What? Not bingo. Why didn't it like that? Oh, I know what I did. I put in a little 2 instead of big 2. 2x to the power of 2, or, I should have just done this, 2x squared, right, plus 1. But you can't combine them. Okay, there it is. Okay, the 2 makes it a little bit narrower than just a regular x squared, but let's not worry about that right now, okay? Quadratic makes a parabola shape. And this 2's what does it, right? What's the degree? 2, right? Degree 1, that's what makes it a line. If there is no degree, or if your degree is 0, it's just a constant. It's still a line, but it's a constant. So that was, I don't know, grade 7, grade 8, grade 9, grade 10, grade 11. Now, you guys are in grade 12. So what's 1 more than degree 2? Degree 3. And you don't have to have all this stuff in there, but let's put it all in there. The leading coefficient is the one that matters. Okay, that's what dictates the shape. I know it's got an x squared in here, but it doesn't look like a parabola. Okay, it's got an x term, but it doesn't look like a line. And it's got a constant, and it doesn't look like a line. The cubed is what makes it look like that funky shape. So let's just put that thing in and see what happens. 3x to the power of 3 plus x squared minus 2x plus 2. Yippee-yi-oo. Okay, now there is characteristics of this thing. It always does certain things because of this cube. But let's just draw the picture of that guy. Okay, it goes down in, what quadrant is this down here? Anybody? And then up in this quadrant. Okay, there is arrowheads on that. It doesn't just stop there. It goes forever and ever and ever and ever. Okay, it goes down in the third quadrant and it goes up in the first quadrant. And if this is positive, it always does that. This is called a cubic. Okay? And that's the shape it makes. All this funny stuff here around this area, okay, that's from all this extra stuff that happens in here. Okay, but guess what this point is right there? If x is 0, do you think that might be 2? Is that what we call a y-intercept? Yeah, so all of this stuff, it still happens. A lot of these same characteristics. Okay, so that's what's new. Well, I might as well put it here since I said it. So that is positive. It does that. Now what happens if I just make the leading coefficient insert a negative there? This went up in quadrant 1. Okay? It went down in quadrant 3. What do you think that little minus is going to do? Quadrant 2, quadrant 4. That always happens. Okay, this is a negative cubic. Okay? So this is quadrant 1, 2, 3, 4. And note, it's in these two quadrants, okay? If it's positive, it's in quadrants 1 and 3. So we'll probably be saying that again real soon, but may as well put it here now. Speaking of characteristics, doesn't want to move that much. Let's do that. So, x-intercepts. This has meaning in the real world. Okay, it means stuff, and you've been doing it in maybe 9, but definitely 10. Okay. And in Math 10, though, you're not allowed one of these guys. You remember how to do an x-intercept on here? Because you've all been through grade 11. Second function, calculate a 0. Okay, x-intercept, it's a 0. It's also called a root. Okay, same thing. So I think you remember that. I'll just say use 0 function on the TI 83 or 84 if you got it. Okay, should I do that one? Enter. And then you got to go left of the x-intercept. It's left of it. Enter. You got to go right of it. It's right of it. Enter. Guess. Yes, please. And that is your x-intercept at where x is 0.712 and change. Note, what is the y coordinate at the x-intercept? Always, 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 right? Okay. That function? Use 0 function on your calculator. All right. Y-intercepts. This is usually easier just with algebra. Like I say, what happens at the y-intercept? X is 0. That's 2. X is 0. That's 1. X is 0. That's negative 2. Okay? You shouldn't even use your calculator, but there still is a way to do it. Okay, so you graph it. You got that. Hit the trace button, and then just go X is 0. Enter. Y is 2. But we already knew that. Okay? So there is a way to do it. Trace, 0, enter. Okay, but you shouldn't have to, right? You're smart kids, big kids, grade 12, graduating in 10 days, then you don't show up anymore. Okay? So I'll write that, but what you should be doing is substitute 0 into the equation. Okay? So just the one above, f of x is 0 plus 0 minus 0 plus 2 equals 2. Everybody's favorite, domain and range. So let's look at the cubic, because that's what's new. What's the domain for this guy? What is domain? You got a 50-50 chance. It's either x or y. X. What are the x values of that graph? That's what it says when it says domain. What are the x values? Like, is this one of the x values? Sure. Is that one of the x values? Yes. Is this one? Yes. How far does that arrowhead go? Forever. Is there any x value here that isn't on this graph? No. Is there any x value this way that isn't on this graph? That's what this arrowhead means. It not only goes down, it goes out forever. And everything in between. How do we write every possible x value you could think of and then some? X is the set of all real numbers, right? Every graph is different, but that one is all real. Is it any different if it's negative here, this guy? Is that all x values? Sure. How about this parabola? Is that all x values? Does it go out forever and ever and ever? Does it go this way forever and ever and ever? Yes, that's x all real as well. How about this line? Same thing. How about this line? Same thing. Okay? Range, however, does this go up? Like range, you want to look vertically, right? Domain, you want to look horizontally. You're talking x. Range, you're talking y. Goes up forever, goes down forever. Y is also all real. Same thing if it's negative. How about my parabola? Is it all y, everything you can think of? This way it is, but it only goes down to, what's this point right here? Yes, okay? Don't look at degree, but that was actually 1, sorry, not 2. This one was 2. That was 1, right? So, how do I write everything for y above 1? Because I just said it in English, but you can't write that down. And if it's multiple choice, it's not going to have that as one of the answers, right? All the values of y greater than 1. It'll say something in math. It'll say this. Everything greater than or equal to 1. Where y is all real. Okay? Because you have to say that. It could be this. Right? Forever and ever and ever. And then it might be just integers. It might be just whole numbers or something natural. Just natural. Okay? This is all real. It's all the fractions, all the decimals, everything up and above that point. Does this go up and down forever, the line? Yes. So that's all real. Does this line go up and down forever? No. How far up does it go? It's just that point, isn't it? It's not above that point. It's not below that point. That's the only y value there is. That's it. It's not y all real because it's just 3. That's the only point for the range. That's the only y value. Okay? So range, everyone's a bit different there. See above. The only real other new thing here is turning point. So let's look at a new graph. What the heck does that thing say? The cubic. What quadrants does it go up and down in? Who's a real fast learner? Shelly? 3 and 2. That's fine. Someone already answered it. It's a positive cubic, so it goes up in 1 and down in 3. And it still does. Okay? So, can you say exactly what's happening around here? Because if you can't, then maybe you want to make it a little bit bigger. Let's make our window a little smaller. Okay, let's just restrict X a bit and see what happens. Okay, that's a little clearer, isn't it? You can even do that for Y. Let's go from 5 to 5. Whoop, that's not going to work. Okay, still goes up in 1, down in 3, but now it's a little clearer. So if I'm going to graph that guy, okay, looks like it goes right up to the origin. Does that kind of make sense? And then what? It goes down into quadrant 4 and then back up. And there's arrows on there. Don't just draw it like that, okay? It keeps going forever and ever and ever. Turning point, what the heck does that mean? You can maybe even guess, right? Where we used to call it y, now we're calling it f of x. Where this thing goes from increasing to decreasing, or vice versa. So if I start down here in quadrant 3, f of x, think of it as y, gets bigger and bigger and bigger and bigger until it gets to this point. Then what happens? It turns. That's a turning point. It starts getting smaller again. So right there, that's a turning point. Okay? Then it gets smaller, smaller, more negative, more negative, more negative, and what happens right here? Flattens out and gets bigger again. Well, there's another turning point. Okay? So a cubic can have 2 turning points. This one has 2. Okay, that's basically it. They also say something about end behavior, which, you know, it's not that important, but all it means is the end of the line, what does it do? And I already explained this one. For a positive cubic, it goes up in quadrant 1. It goes down in quadrant 3. Okay? End behavior of the lines, that's all they're saying. What quadrant does it go in, basically? Okay, turning point. How many turning points does a line have? None. Right? Okay, it just keeps going up. Or, looking at it from the other perspective, it just keeps going down. Okay, that's it. Today.